Hi everyone. Today we continue our discussion about the production of materials by talking about radioisotopes. And today we'll talk about how to detect certain types of radiation. So there is a number of ways to detect radiation by using the characteristics of alpha, beta, and gamma radiation. So looking at alpha radiation, which is a helium nucleus, it has a very low level of penetration. So it can be stopped by such things as paper. Beta, on the other hand, will go a little bit further, but you will need a metal to stop beta radiation, such as an aluminium sheet. And gamma radiation has very far penetrating properties. So you need a heavy metal to stop gamma radiation, such as lead, like lead vests that they use to stop that kind of radiation. So let's look at a Geiger counter. Now, an ionisation counter is an instrument for detecting and measuring radiation. The most familiar type is the Geiger-Muller or Geiger counter, and this is named after the two German scientists that discovered it. So this is how it works. What we have is a metal tube here, which has argon atoms. And at the end, we have a window. And ionising radiation can come into this window, and what happens is the radiation will actually hit these argon atoms and cause electrons to be dispelled from the argon atom, therefore producing positive argon ions, cations even. So the radiation causes the argon atoms to be ionised, and it forms positive ions and free electrons. And the cations, or positive ions, and the electrons produced by this radiation that comes in here will conduct current, and so therefore it can be detected. So that's why we hook it up here to the negative terminal of a DC power supply and a central wire electrode to the positive terminal, and we can count how much ionising radiation is actually going through this Geiger counter. So the argon ions and the free electrons allow a current to flow between the electrodes, and each time the tube is exposed to radiation, these bursts of current are converted into audible clicks. So you may have heard it when you get a Geiger counter, it goes every time you get close to radiation, and it'll be audible clicks, or you can also convert it into a digital readout so you can see how much radiation is actually happening here. So another way of detecting radiation is through photographic film, and a long time ago, about 100 years ago, a French scientist called Becquerel actually discovered that radioactivity, he discovered radioactivity by observing the effect of radioactive emissions on photographic film. And the degree of darkening on his photographic film actually increased with the length of exposure and the intensity of the radiation. And he actually discovered the first means for measuring radiation. And it's used today by people who work with radiation, either scientists or medical staff, that sort of thing. And they have to wear one of these badges, which contains photographic film, which monitors their level of exposure so that they make sure that they're not getting too much radiation, because it's not really that good for you. So another way of looking at radiation is the use of Tlds, thermoluminescent dosimeters. And it's very similar to the photographic film, and it's worn by workers that are using radioactive substances to measure their exposure. They contain crystals of an inorganic salt, such as calcium fluoride, lithium fluoride, or potassium bromide, and these absorb radiation and emit light when they're heated. And the amount of light emitted is determined by the amount of exposure to radiation. So it's another way these workers can be monitored as to how much radiation they're being exposed to. Okay, so ascertain their level of exposure. Another way, and this is more in the laboratory, is something called a cloud chamber, and it's more used by physicists really, and research laboratories to investigate radiation produced by nuclear reactions. The radiation interacts with a cold supersaturated alcohol vapour, which condenses around ions that are formed during the ionisation of the air. And you can actually get a picture of this. and it forms cloud-like trails showing the path of the radiation. So there's our picture, which looks like a bit of a scratched window, but that's actually showing the radiation of alpha particle decay. So it is common to surround these cloud chambers with electric and magnetic fields to investigate the properties of radiation. So this is more getting into your nuclear physics sort of research area. So alpha particles form intense but short, as you can see on the picture, intense but short straight tracks because of their high ionizing abilities but low penetration. And finally, scintillation counters is another way we can measure radiation. So some substances, such as zinc sulfide, will actually produce a flash of light, or a scintillation, when struck by ionising radiation. So what's happening here is the electrons are actually excited, so they jump up a level by the radiation, and when they come back down, they'll emit a photon, and so there'll be a flash. And by using a machine like that one there, which is quite modern, you can actually measure how much light, how many flashes, as to how much radiation is going on. So the flashes of light are counted electronically to measure the amount of radiation. So that's our theory about how we detect radiation. So let's look at a few questions now. Question 1, which of the following instruments or devices can be used to detect radiation? So we discussed Geiger counters. So Geiger counters, or Geiger-Muller tubes, detect ionising radiation, primarily alpha and to a lesser extent beta emissions. So definitely Geiger-Muller tubes is on our radar for this question. And of course, as I discussed earlier, photographic film will absorb radiation and become darker when exposed to the radiation. So our answer has to be photographic film and Geiger-Muller tubes. Question 2, describe how Geiger-Muller tubes detect radiation. So here's a diagram of our Geiger counter or Geiger-Muller tube. So alpha and beta radiation will enter the tube through this little window here. Okay, it's filled with argon gas, and it will ionize some of the argon atoms to form positive ions and free electrons. The gaseous argon cations, okay, so they're positive now once they've been hit by the radiation, will allow a current to flow between the electrodes, okay, up here. And these bursts of current are converted to audible clicks on a built-in speaker, or they can be converted into a digital readout, depending on the type of Geiger counter. Question 3. Thermoluminescent dosimeters, or TLDs, this is just a bit of background before we get to the question, are worn by workers using radioactive substances. They contain crystals of an inorganic salt, such as lithium fluoride, as I mentioned before, that absorbs radiation when heated and emits light. The amount of light emitted is determined by the amount of exposure to radiation. So our question, what is the purpose of wearing TLDs? These are our options here, and I really love part C, to provide a pretty brooch that glows when it's hot. Don't put part C, as funny as it is. So let's look at it. The amount of radiation the TLD absorbs is indicative of the level of radiation, but it does not protect the person from the radiation. So it will tell you how much radiation that you're taking in a given environment, but of course it's not going to protect you. So that's the important part about TLDs. So our answer is to measure the person's exposure to the radiation. Question 4, describe how a scintillation counter works. Okay, so some substances, such as zinc sulfide, will produce a flash of light when struck by ionising radiation, primarily alpha and beta particles, so the less penetrating type of radiation. And this can be measured. So their electrons are excited by the radiation, and they'll emit photons of light, and return, when the electrons return to a lower energy state, the photons will be released, and this can be counted. So the amount of photon energy given off can be measured, and there you go, the amount of radiation can be determined using a scintillation counter. And finally, question 5. What happens if workers receive a higher than acceptable radiation dose? The TLD or other device that they're using will register this high exposure, and the person will be removed from the area where the radiation is present and examined by medical personnel. So it's very, very strict when you're working with radiation, that you always have to wear a device so that you get monitored as to how much radiation you're taking in. And the person won't be allowed to return to the area until it's considered safe and everyone's happy. So that wraps up our story about radioisotopes today and how we measure them. And in the next section, we'll be talking about how we actually make commercially important radioisotopes.